Hello everybody. So let's continue with Module 14, Lesson 14.2, Polygons in the Coordinate Plane. And our essential question is, how can we solve problems by drawing polygons in the coordinate plane? And we're on page 409 of the 6th grade Go Math middle school textbook. All right. So a polygon, as you'll remember, is a closed plane figure formed by three or more line segments that meet only at their endpoints. A vertex is the point where the two sides of a polygon meet, and the vertices of a polygon can be represented as ordered pairs, and the polygon can be drawn in the coordinate plane. So, for example, Sheila wants to make a pattern of two different tile shapes on a floor. She first graphs the shapes on a coordinate plane. So in this assignment, or this task, we're going to plot these points, and we're going to connect the points in order and see what shape we make. So let's start with point A, and that's located at 3, 5. And then B is at 4, 6. Okay. And then 5, 5. And 4, 4. Okay, so what polygon did we form? We made a square. Now plot these points to form the other tile shape. So we're at negative 5, 2, point P, negative 4, 3, point Q, 0, 3, that's R. We can go ahead and connect those as we go along. Oh, I put this as 2.5. I'm not sure why I did that. 0, 3. 1, 2. That's point S. 1, negative 2. It's point T. 0, negative 3 for U. V is at negative 4, negative 3. And W at negative 5, negative 2. Okay, and what shape have we created here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have an octagon. All right, so how is the number of vertices related to the number of sides of the polygon and to the type of polygon? Well, you'll remember that the number of vertices equals the number of sides in a shape. So for instance, we have a quadrilateral here, a square, and it has 4 vertices. The one we just made has 8 vertices, and that's an octagon. So on. So the number of vertices equals the number of sides. All right, so the number of vertices, as we saw in our two examples on the coordinate plane, equals the number of sides. Well, then that means that the number of vertices can be used to name the polygon. If you have 3 vertices, you'd make a triangle. If you had 6 vertices, you'd make a hexagon. All right, so how about finding the perimeter then in the coordinate plane? So we can use what we know about finding length in the coordinate plane to find the perimeter of a polygon. So we can use lesson 14.1 where we found the distance of sides, or the distance between 2 points, to help us find the perimeter of a polygon. So the grid shows the path Tommy followed when he walked from his home at 0, 0, 0 to various locations and back home again. If each grid square represents 1 block, how many blocks did he walk? And so here are our points. Home, the library's at 0, 4, the park's at 5, 4, his friend's house at 5, 2, the pond's at 7, 2, and the store's at 7, 0. So find each distance, and each grid unit represents 1 block. So from his home to the library, so we see that the x-coordinates is the same, so we're going to use the absolute value of 0 and 4. These two are on the same y-axis, so we're going to subtract, and 4 take away 0 is 4. So 4 blocks. Now from the library to the park, the library's at 0, 4, the park's at 5, 4. So this time the y-axis, the y-coordinates are the same, so we're going to use 0 and 5. We're still in the first quadrant. Okay, so we're going to subtract again. And so the absolute value of 5, take away 0 is 5 blocks. The park to Tommy's friend's house. So we're still in the first quadrant. So we're going to subtract the absolute value of 4 and the absolute value of 2 to get 2 more blocks. From his friend's house to the pond, the y-coordinates are the same, but we're still in the first quadrant. So absolute value of 7, take away the absolute value of 5, gives us 2 blocks. The pond to the store, the absolute value of 2, take away the absolute value of 0, gives us 2 blocks. And finally, from his store to his home will be the absolute value of 7, take away 0, or 7 blocks. Then we can add up all of those different spots, okay, of this shape. So we have 4 plus 5 plus 2 plus 2 plus 2 plus 7, or 22 blocks. All right, so let's practice one ourselves. Number 2. Suppose the next day, Tommy walks from his home to the mall at 08 and then walks to a movie theater at 78. After leaving the theater, Tommy walks to the store at 70 before returning home. So home, again, is 00. To the movie theater, no, I'm sorry. Yeah, the home is 00. To the mall is 08. So how many blocks is that? That would be absolute value of 8 minus absolute value, 0 is 8. So 8 blocks. So home is at 00. The mall was at 08. He's then going to go to the movie theater. So we're at 08. Theater is at 78. So we're going to take the absolute value of 7 and subtract 0, which would be 7 blocks. He's then going to walk to the store. So he's at 78. And he's now going to go to the store at 70. So we're going to take the absolute value of 8, subtract 0, and that's going to give us 8. And then he's going to go from the store to home. So he's at the store, 70, and he's going to go home at 00. So we're going to go 7, the absolute value of 7, take away 0, and we're going to get 7. So we're going to add 8 plus 7 plus 8 plus 7. So 8 and 7 is 15. 15 and 15 is 30 blocks. Okay, we can also use it to find the area in the coordinate plane. And we're going to use basic area formulas to help us find the areas of these polygons. So in example 2, Caleb is planning a new deck for his house. He graphs the deck as polygon A, B, C, D, E, F on a coordinate plane, in which each grid unit represents 1 foot. The vertices of the polygon are point A, 1, 0, point B, 3, 2, point C, 3, 5, point D, 8, 5, point E, 8, 2, and F, 6, 0. And we have to find the area of Caleb's desk. So once you graph the points, connect them in order, you get this shape that shows up on the grid. So we have a rectangle and a parallelogram. Well, so let's find the area of the rectangle by using the length of segments BE as the base and the length of BC as the height. Around a rectangle, we can find base times height or length times width. So the base of B to E would be 8 minus 3. We're in the same quadrant. So 8 minus 3 would be 5 feet. And 5 take away 2 would give us 3 feet for BC. Well, 5 times 3, 15 square feet. So the parallelogram is 15 square feet. Now the area of the parallelogram, sorry, we were doing the rectangle, 15 square feet. The area of the parallelogram is still the same formula, base times height. In this case, we're going to use line segment AF, okay, which is 6 minus 1, so 5 feet. And we're going to use a height of F to 6.2. So 60 to 6.2. In other words, we're going straight up here to find the height, right? I could use this point here. I could use this point, okay? Anything that would be the height of the parallelogram. So we see that 2 take away 0 would be 2 feet. So 5 times 2, 10. So the parallelogram is 10 square feet. So we add those together, 10 plus 15, we get 25 square feet. All right, so let's try this. Number 3. The vertices of a polygon are L, M, N, O, P, and Q. So let's graph the polygon, then find its areas. L, 1, 2. M is at 1, 6. N is at 7, 6. 7. 7, 6. O is at 7, 2. P is at 5, 0. And Q is at 3, 0. Okay, so we see that we can make a rectangle and a trapezoid. So the area of the rectangle would be base times height. We're going to use M to N, or you can use L to O for the base of the rectangle. And so we have 7 minus 1, which would give us 6 for the base. The height, we're going to use L to M or O to N. And so M is 6, N is 2. So 6 minus 2 gives us a height of 4. So the rectangle is 24 square units. Now for the trapezoid, we're going to use area equals 1/2 the height times the sum of base 1 plus base 2. Okay, the height of the trapezoid, I can use 3, 2. I can use, 3, 0 and 3, 2 to find the height. So 2 take away 0 gives us 2. So we have a height of 2. And base 1 and base 2. Well, we're going to use the same base as, one of the bases is going to be the same as the rectangle. So we're going to have 6 plus the distance between point P and Q. So 5 minus 3 gives us 2. So half of 2 is 1, obviously, and 6 plus 2 is 8. So we have 24 plus 8. 32 square units. All right, let's continue on to page 412. All right, so a gardener uses a grid to design a new garden. The gardener uses polygon WXYZ on the grid to represent the garden, and the vertices of this polygon are 3, 3, negative 3, 3, negative 3, negative 3, 3, negative 3. So we have 4 vertices, so we know we're going to be making a quadrilateral. So let's go ahead and plot these points. 3, 3. It looks like each unit is 1, so 1, 2, 3, up 3. 1, 2, 3. All right, so there's point W. X is at negative 3, 3. So basically it's reflected across the y-axis. Negative 3, negative 3 for y. Negative 3, negative 3. And then that got reflected. 3, negative 3 for z. All right, so W to X, X to Y, and Y to Z. And then close it. All right, so we basically made a square, right? Okay, so what is the shape of the garden? It's a square. How much fencing will the gardener need to enclose the garden? To enclose the garden, that would be perimeter. Okay, we're going to go around the fence. So from X to W, we have 3, 3, and negative 3, 3. Okay, so we're in different quadrants. W and X are in different quadrants, so we're going to add the absolute values of 3 and an absolute value of negative 3. So 6. So all sides are 6, and 6 times 4 would be 24 yards. Oh, no, I'm sorry. Each side of the garden is 6 yards. The gardener will need 24 yards of fencing, because all we have to do is go 6 times 4 to get the perimeter. So what's the area of the garden? Well, the area is S squared, or you could say area equals base times height. And in this case, it's 6 times 6, 36 square yards. Okay, number 4. A clothing designer makes letters for varsity jackets by graphing the letters as polygons on a coordinate plane. One of the letters is polygon A, B, C, D, E, F. The vertices are, so there's 6 vertices. These are their coordinates. So we're going to be making a hexagon basically, and each grid is 1 inch. So let's start with A, 3, -2. All right, and then B is at 3, -4. C is at -3, -4. D is at -3, -3, 4. E is at -1, 4. F is at -1, -2. All right, and then we'll just finish by closing it, joining F to A. All right, so the letter she made is capital L. Identify the letter L. Find its area. We got a couple options here. I'm going to break this into just 2 rectangles, basically. Okay. So I'm going to divide it this way. Okay. There's multiple ways you could divide this shape. I'm going to break it into 2 rectangles. And so we have area equals base times height of rectangle 1. I'm going to call this 1 and this rectangle 2. So rectangle 1, we're going to say the base is 1, 2, 3, 4, 5, 6, 8 units. And the height is 2. So the area of this one is 16 square inches. And then rectangle 2, still base times height. We have a base of 1, 2, 3, 4 units. And we have a height of 2 units. So rectangle 2 is 8 square units. So the area is 16 plus 8, which equals 24 square inches. All right, number 5. How can you use a coordinate plane to solve perimeter and area problems? Okay, so what did we basically do? We plotted the points, right? We plotted the polygon on the coordinate plane, and then we found the length of the sides of the polygon, and then we used formulas to find the area and perimeter. So all right, so plot the polygon on the coordinate plane, find the length of each side, and then use familiar formulas to find the area or the perimeter. right, let's move on to 413. And number 6. A graphic designer creates letters for wall art by first graphing the letters as polygons on a coordinate plane. One of the letters is polygon MNOPQRSTUV with vertices, and these vertices are their points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices, which we know as a decagon. So graph the points and let's see what letter we're forming. M is at 2, 1. N is at 2, 9. And we can join these as we go. O is at 7, 9. P is at 7, 7. Q is at 4, 7. R is at 4, 6, over 4, up 6. S is at 6, 6. T is at 6, 4. U is at 4, 4. V is at 4, 1. Okay. And we need to complete it by closing it. So we get the capital letter F. All right, so F is formed. Designer uses decorative tape to paint the outline of the letter on a wall. How many inches of tape are needed? So what are the total units of our shape? Well, from N to O, basically we have 7 minus 2. 7 minus 2, that would give us the distance of 5. Okay, from N to M, we have 1 and 9, so that's going to be 8 units. We have M to V, which is just 2 units. From V to U, we have 3 units. From U to T, we have 2 units. From S to T, we have 2 more units. From S to R, 2 units. Q to P, 3. And P to O, 2. So let's just add those all up for the final perimeter. 5 plus 2 plus 3 plus 2. And we actually have 1 here. Q to R is just 1. So let's see. 5 plus 2 plus 3 plus 1 plus 2 plus 2 plus 2 plus 3 plus 2 plus 8. Okay. So we get 5, 7, 10 plus 5 plus 15. So 15 plus 15, 30. So we get a distance of 30 inches. C, how much space does the letter cover on the wall? Okay, so this one, how much area does it cover? Well, I don't have a formula that does one for a decagon, right, with all these multiple sides. So what I need to do is break it into familiar shapes. And I know I can look at that and break it into several different rectangles. So I think I'm going to go across here. Okay, that's going to form one of mine. And then I think I'm going to go here. So I'm going to have 3 rectangles. So rectangle 1 is going to be 5 times 2. So that's going to be 10 square units. The small rectangle here for rectangle 2 will be simply 2 times 2 equals 4 square inches. And then the longer one here, it's not 8 because all the way up is 8. So we have to subtract this small piece here. So 8 take away 2 is 6. And we have a height of 2. So we have an area of 12. So the area is 10 plus 4 plus 12. So the area is 26 square inches. How did you find your answer to? I used 3 rectangles and added the areas together. All right, 7. The polygon shown is a regular polygon. Okay, so regular is a clue that all sides are equal. And it says that because all sides have equal length and all angles have the same measure. So the polygon is a 1, 2, 3, 4, 5, 6 is a regular hexagon. What is the perimeter of the hexagon? Well, all the sides are equal, right? So what is the distance from this point to this point? Well, we have a distance of 6 take away 3. So 3. So 6 times 3, 18. 18 units. C. A line can divide the figure into 2 identical 4-sided figures, 4-sided polygons. Each polygon has 2 bases, and one base is twice the length of the other base. Identify the polygon and give its perimeter. Okay, well, if we divided this straight across, we'd have 2 hexagons. Not 2 hexagons. We'd have 2 trapezoids. So we'd have a trapezoid. And we have to give the perimeter of the trapezoid. So what does it tell us? Each polygon has 2 bases, and one base is twice the length of the other. Well, we know that this was 3, right? So that has to be 6. So what's the perimeter of that? 3 plus 3 plus 3 plus 6. 15. 15 units is the perimeter. Because P equals 3 plus 3 plus 3 plus 6. All right, 8A. Jean wants to put furniture in her clubhouse. She drew a floor plan of the clubhouse. As shown, and each grid unit represents 1 foot. Which polygon names the shape of the floor? Well, we have 1, 2, 3, 4, 5, 6 vertices. So we have a hexagon. And how many feet of baseboard are needed to go around the entire clubhouse? So we need the perimeter, right? All right, well, they're telling us that this line here is 5. This line is 5. This is only 1. This has a distance of 2. This one goes from 4 to -5. So we're going to add the absolute values of 4 and 5. That would give us 9. This is just 2. Okay. Now we just have to add them up. So we'd have 1 plus 2 plus 5 plus 9 plus 2 plus 5. So 8 plus 16, 24 feet. Okay. How much carpet is needed for the clubhouse floor? Okay, so what shapes can we make? I think I can, let's see. I have this triangle. I could have this rectangle. Okay, this skinny, tall rectangle. And then the rest, this other one could be a trapezoid. So we have a trapezoid, a rectangle, and a triangle. Okay, so what is the area of each one? So the trapezoid is 1/2 the height times the sum of base 1 and base 2. The rectangle would be base times height, and the triangle is 1/2 the base times the height. And we need to add those all together to get the total area. So what's the base of the trapezoid? Well, one of the bases is 2, and the other base is 1, 2, 3, 4, 5. The height is from here to here. So it's from -1 to -5. So that's a distance of 4. Okay, so the area of the trapezoid is 1/2 of 4 times the base 1 and base 2, which is 7. So 1/2 4 is 2. 2 times 7 is 14. All right, so the trapezoid area is 14 square units. The rectangle is 1, 2, 3, 4, 5. Has a base of 5. Has a base of 1 and a height of 5. So 5 square units. And the triangle, the base of the triangle is 1, 2, 3, 4 units. And its height is 1, 2, 3 units. So 1/2 of 4 is 2. 2 times 3 is 6. So we have area equals 14 plus 6 plus 5, 25 square feet. Is this the only way to solve that? No, you might have saw some different shapes in there, and that's fine. Maybe you made 2 triangles. Maybe you made 2 rectangles. I don't know. It just depends on how you saw the shape. Okay. All right. Number 9. So persevere in problem solving. So to find the area of triangle ABC, Jen first drew a square around the figure. 2 sides of the square pass through points A . Two sides of the square pass through the points B and C, and the other 2 sides met at point A. Draw Jen's square and explain how you can use it to find the area of a triangle ABC. All right. So basically what they're saying is Jen went, what is the area if this whole shape was a square? And we'd have a 5 by 5, right? So the area would be area of square equals 25. And then we have 3 small triangles we're going to subtract the area from. Okay, so it doesn't matter which ones you call 1 or 2 or 3. So we're going to use the area of triangle formula. So here's our first empty triangle, and that has a base of 1, 2, 3, and it has a height of 5. So half of 15 is 7.5. This one right here, we have a base of 2, and we have a height of 1, 2, 3. So half of 6 is 3. And triangle 3, we have a base of 1, 2, 3, 4, 5. And we have a height of 2. So we have half of 10, basically. Half of 10 is 5. So we'd have 25 minus 7.5 plus 3 plus 5. So 25 minus 15.5 equals 9.5 square units. Okay. All right, 10. The coordinates A 5, -2, B 3, -1, C -4, -4, D -3, 8, and E -1, 4 form the vertices of a polygon when they are connected in order from A through E. Classify the polygon without plotting the points. Remember, each coordinate is a vertex of the polygon. So we have 1, 2, 3, 4, 5. So we have a pentagon. Okay, so shape's a pentagon. It has 5 points, or we can consider those vertices. So the shape's going to have 5 sides. So that makes it a pentagon. 11. Josh's teacher draws a regular octagon. Regular octagon. All sides equal, right? On a coordinate plane. One side has endpoints 1, 5, 4, 5. Josh says he can't find the perimeter of the octagon because he only finds lengths of horizontal and vertical line segments. He says he can't find the lengths of the slanted sides of the octagon. Well, yeah, he can, right? Because it says a regular octagon. So if one of the horizontal segments, you know the distance, you know all of the distances. So okay, so what is the distance? So it's going to be 4 minus 1, which gives us 3. So the perimeter is 8 times 3, which equals 24 units. And 12. Give coordinates for the vertices of a triangle that could have an area of 35 square units. Prove that your triangle fits the description by finding its area. All right, well, let's start with the area formula. 1/2 the base times the height. They're telling us that the area is 35. Okay, well, if we multiply both sides by 2, we get 70 equals the base times the height. So basically we need a figure that has a base of 10 and like a height of 7, or a base of 7 and a height of 10. So either way, so we need something that's 10 by 7. So let's say we have a point at 0, 0, right? And then we're going to have another point at 10, 0. Well, that would be a distance of 10, right? Okay, and then we'd have to have a height of 7. So if we're at 10, 0 and we need a height of 7, then we'd have to be at 10, 7. That would give me a height of 7. And then we would just connect it there. Okay. Okay. So that's just one possibility. The base has to come out to 10, a distance of 10, and a height of 7, or vice versa. Okay. Or you could have something like a height of 5 and a base of 14. That would be 70. We just need two numbers multiplied together to give us 70. I suppose you could have a 2 by 35. Okay. So that's how we use the coordinate plane to find and solve area and perimeter problems. So until next time, I will see you soon.